Hi, I'm Vishweshwar. Now let's see the wireless security WEP and WPA. When we say wireless communication, obviously it provides a potential security issue because there is no physical access and the traditional wire system to gain or to access a communication, a data communication. So here the wireless communication is essential and it requires a number of technical safeguards to protect your confidentiality and integrity. That's the reason we are making the wireless secure with a password. So here is of two types, the WEP and WPA. WEP stands for wired equivalent privacy and WPA is the Wi-Fi protected access. So let us see what is WEP now. We know the wireless standard given by the IEEE is 802.11. And wireless is also a shared medium where everything can be transmitted or you can receive it. But it also we need to overcome the interrupters that come in between, means the hackers. So here the WEP acts like an algorithm to protect your wireless communication from your hackers. So the WEP thus consists a secret key. We're gonna give a secret key or gonna use a secret key between mobile stations. Here the mobile station means the laptop with a wireless Ethernet card. The laptop which has the wireless capability. And when you try to connect to an access point is nothing but like a Wi-Fi. So you're trying to connect with a password from one point, which gives the wireless signal to your laptops. So the secret key is used to encrypt the packets before it transmits, and integrity check is used to ensure the packets are not modified during the transmission, which means while you are connected wirelessly with a password and you are trying to do some transactions or some transmission, sending or receiving data, while doing that, we should ensure that the packets that you send or receive should not be modified. That's the reason we are making it secure with a Wi-Fi password. That's nothing but the WEP. These are some of the following things that are implemented in the wireless networks, in the WEP wireless networks. You have a 64-bit WEP key. It's a kind of secret key that we create with 5 characters, means a password, and a 64-bit key with 10 hexadecimal digits also. Here it contains numbers. Similarly for 128, there is 13 characters, and for 128, there is also 26 hexadecimal, that is numbers. So this is WEP. And here is a setup. Here is a page that is to modify or to make some setup changes for the base station with WEP configuration. So here is the network name that you give. The SSID is the place where you give the name, and you have a WEP encryption here, and you have a choice to change whether it's a 64 or 128, and you also have to give some keys, a default keys to connect with the wireless. And so these are some of the key settings that we do for the base station to make to encrypt your wireless data. And here is a good example like how to give a WEP key. So WEP 64-bit, we said like a 64-bit with characters should be like a combination of numbers and characters. So these are some of the examples that you can try to give for the WEP key. And for 64-bit hexadecimal key, it contain like a hexadecimal numbers. So these are some of the examples of it. Issues or drawback with WEP. So the key of the WEP remains the same until the administrator tries to change it manually. So the 64-bit and 128-bit, the password can be hacked very easily within few minutes using some third-party softwares. And the WEP is not so strong enough that is determined, and it affects the WEP also, like the encryption technologies very casual to use. It's not suitable for an enterprise level. Means it's not suitable for a big level. Only okay for a domestic level that is used in homes or connecting appliances. And if two or more packets are received or the two or more packets are hacked by the hackers, it's easy to get the key because all the packet will have the same key. So the only solution for in order to make this WEP secure is that it constantly changing the key of WEP. So this is the only solution. WPA, Wi-Fi Protected Access. Though it is a kind of a security protocol in IEEE 802.11 standard, which was developed especially for wireless to authenticate and to protect the wireless users from the network access. And it is superior than WEP. The WPA has two categories, that's the WPA PSK and WPA Extended Authentication. The WPA is the security protocol, but the encryption technique here is the PSK or an external authentication. So let us see that in detail now. The WPA PSK, that's a pre-shared key. It specifies a protocol called TKIP, that's a temporary key integrity protocol, where it is especially used for the security level in SOHO. SOHO means small office, home office. That's a small network. That's for a small kind of a limited computer network. And the TKIP replaces the WEP because the new encryption algorithm is completely making facility to for the existing wireless devices also to connect. So it makes more facility also to connect various devices which was connected previously with WEP. And the TKIP also provides some of the following advantages is that it changes the unicast of encryption key for each frame. So the unicast encryption key for a frame usually changes very often. And the unicast key is also for changes for also the pre-shared key authentication. It is used for the purpose of pre-shared key authentication. The TKIP also very often changes the key in between the synchronizing between a communication between the wireless client and the wireless access point. So there is a continuous interaction and a continuous change in the key so that it can make more protected. And the WPA gives a big facilities that we can change the key which is connected wirelessly to the clients. It's very often we as a wireless clients can also change the password manually to make it more secure. The WPA External Authentication. This is a type of a authentication protocol where the issues are challenged to the wireless supplicants. And here there is an identity to the authentication where it forwards and supplies to the radius server to initiate the authentication service. A request is passed between the control of the radius server, and it also allows communication with an authentication key. So let us see all these informations here in a diagram. The WPA external authentication using the radius server. Let us see that in a diagram. Here we have an end user station, that's a client, and there is a wireless access point to access the wireless networks, and the password is also exchanged from the radius, and it is done with an authentication key. So there are four steps involved in this. Let us see that one by one. The first step is that the end user station gives a request it to the wireless access point. to get an authentication. So the end user station at first initially gives a request to the wireless access point for an authentication. And the next step here is the wireless point access that information request to the radius server. So from the end user to the wireless access point, and from the wireless access point it gives a request to the radius server. And the third step is the radius server here, it challenges the end user station for a password, and the end user responds with a password to the radius server. It tries to connect with the right password. So here the radius server is not giving a password. The end user is trying to connect through the access point to the radius server with a password. And the fourth step is if the password is right, or if the password is matched to the existing password, it authenticates. Now the radius server authenticates and opens up the port so that the end user here can access the wireless means a wireless access point in order to make his data communication. So this is how the wireless access point and connecting to the client works.